Hello everyone, my name is Tejishri Divakar Dasi. I am from Sri Siddheshwar Women's College of Engineering, Solapur. I am pursuing BTech from Computer Science Engineering currently in first year. So I am here to explain one of the concepts of engineering physics, that is GM counter. In this lecture we are going to see introduction, what is GM counter, construction and working of a GM counter. So let us start. We'll see first what is GM counter. So GM counter, that is Geiger Muller counter, is used for detecting and measuring the radiations like alpha particles, beta particles and gamma rays, etc. The GM counter is shown in the figure. Let us understand the construction of GM counter. So as you can see in the figure, GM counter consists of a hollow metal cylinder. This hollow metal cylinder acts as cathode. A fine tungsten wire is stretched along the axis of the tube. This fine tungsten wire acts as anode. The fine tungsten wire is connected to the positive terminal of a high tension battery through resistance R, and the negative terminal of a battery is connected to the metal cylinder, which acts as cathode. And at one end of the tube a thin window of mica is arranged. This mica window is arranged to allow the entry of radiation into the tube. Let's move forward and see the working of a GM counter. Initially, the GM counter is filled with a low pressure inert gas such as argon or neon. A small amount of quenching gas like alcohol vapor or halogen is also added. A thin wire runs along the axis of the tube and acts as the anode. And as we have seen that metal wall of the tube acts as a cathode. A high voltage of about 400 to 900 volt is applied between the anode and cathode. When ionizing radiation like alpha, beta or gamma rays enters the tube through the mica window, it passes through the gas. As it travels through the gas, it collides with gas atoms. These collisions ionize the gas atoms. Each collision produces free electrons and positive ions. This process is called primary ionization. Due to the applied high voltage, electrons move rapidly towards the positively charged anode. Positive ions move slowly towards the cathode. The electric field strength increases sharply near the anode wire. The electrons and ions of argon thus produced cause the other argon atoms to ionize. This causes further ionization, producing more electrons and ions. The process multiplies rapidly, forming an electron avalanche. That causes a current pulse. That is, the sudden movement of electrons towards the anode produces a strong current pulse. This pulse is large, almost independent of the energy of incoming radiation. The pulse travels through the external circuit. The current through R produces a voltage pulse of the order of 10 microvolt. An electron pulse amplifier accepts the small pulse voltage and amplifies them up to 5 to 50 volt. The amplified output is then applied to a counter. As each incoming particle produces a pulse, the number of incoming particles can be counted. Each pulse represents one detected radiation particle. Due to high voltage between anode and cathode, avalanche effect takes place. An avalanche is a process in which a number of free electrons in a medium is subjected to a strong acceleration by an electric field and collide with other atoms in the medium, and thereby ionization takes place. There are three main concepts in the working of GM counter, that is dead time, plateau region and quenching. Dead time is the time period for which the counter is incapable of detecting any further nuclear particle. The dead time for GM counter is 200 to 400 microseconds. For a short time after each pulse, the tube cannot detect another particle. This is nothing but dead time. After recovery, the GM counter resumes normal operation. Then it comes plateau region, the range of applied voltage over which counting rate remains constant is nothing but plateau region. Quenching process. When free electrons recombine with positive argon ions, they form neutral argon atoms. This process leads to the emission of photons. This results in unwanted pulse. So, the method of suppressing unwanted pulse generated by these photons is called quenching. Quenching, that is suppressing the unwanted pulse produced by photon, can be achieved by adding ethanol. Ethanol molecules absorbs the generated photons and suppress the unwanted pulse. Now we will see the advantages and disadvantages of GM counter. Here are the advantages of GM counter. GM counter is used to detect nuclear radiations and charged particles like beta and gamma. It is also used to measure cosmic ray intensities. The main advantage of GM counter is counter setup is light in weight and portable, and it is best for mineral prospecting. The disadvantages of GM counter are it has large dead time which limits the counter rate. Also, it cannot be detect neutral particles, and it has low efficiency for detecting gamma radiations. So this was all about GM counter. I hope you understand this very well. Thank you.